Hi everyone. This week we're going to continue solving systems of linear and quadratic equations. So this is part 2 of the lesson. So a quick reminder that a quadratic and a linear function can have two solutions if it intersects at 2 points, one solution if it intersects only at 1 point, or no solution like in this last graph if the line and the parabola do not intersect. Another way to solve these types of systems is by graphing them. So here we have y equals x squared minus 4x plus 4. If you do it by hand, then you have to actually create a table of values. So for the first equation, we're going to run a few values of x and y. Let's go ahead and start with 0. So if y is 0, if x is 0, then y is 4. Everything cancels except the 4. If x is 1 squared minus 4 times 1 plus 4, that's going to be 1 minus 4 is negative 3 plus 4 is 1. If x is 2 squared minus 4 times 2 plus 4, that's going to be 4 minus 8 plus 4, that's going to be 0. And if x is 3 squared is 9 minus 12, that's going to be negative 3 plus 4 is 1. So let's graph all these numbers. So the first one is 0, 4, about here. 1, 1, down here. 2, 0, and then 3, 1. See how it starts going back up? So this is going to be the parabola. And now for the linear function, if x is 0, then y is negative 2. If x is 1, y is negative 1. If x is 2, y is 0. If x is 3, y is 1. So let's start graphing these. 0, negative 2, 1, negative 1, 0, 2, 3, 1. So I'm actually going to use a ruler to try to make the line straight as possible. Okay, I know it's kind of hard to see, but the parabola and the line intercept at 2 points. They intercept here and here. They intercept at 2, 0 and 3, 1. So those are your two solutions. You could also graph it using Desmos.com. So it's gonna give you a much cleaner graph. So it's the same two equations, but this time I graphed them on Desmos. I already took a screenshot of it. And the cool thing about Desmos is that you could zoom in and out. So here you could clearly see how they both intersect at 2, 0 and at 3, 1. So depending on the problem, if it tells you to graph it, you're gonna graph it by hand. If it tells you to use Desmos, then you are allowed to use Desmos. Okay. So we know that the solutions are 2, 0, and 3, 1. All right. So I'm gonna let you try that one. This is similar to the one we just did. And then you see how here you could use decimals. So you could solve these two using decimals. Okay, next, find the solutions by substitution. So here, whenever you have two equations equal to the same variable, you could set them equal to each other. So for example, x squared minus 6x plus 4 is equal to y. 4 minus x is equal to y. So therefore, they're equal to each other. So when you set it up, it could look like this. X squared minus 6x plus 10 is equal to 4 minus x. Now you want everything on the same side and you want to set it equal to 0. So you're going to subtract 4 and add x to both sides. So subtract 4 from the 10 and then add x to the negative 6x. So now you have x squared minus 5x plus 6 is equal to 0. Now you're going to solve by factoring. So numbers that multiply to 6 and add up to negative 5 are negative 3 and negative 2. So the factors are x minus 3 and x minus 2. So the numbers that make this 0 are 3 and 2. So those are your x values. You still need to find the y values. And you're going to do that by plugging them in to this first equation here. Okay? So if x is 3, then y is 1. So 3 comma 1 is one answer. And if x is 2, then y would be 2. So 2 comma 2 is the other answer. Okay, so here are your two solutions. Okay, another example number 5. We have y minus 30 is equal to 12x, and y is equal to x squared plus 11x minus 12. Notice the first equation, y is not by itself, but we could fix it. I'm going to copy it over here so I have more room. To get the y by itself, I'm going to add 30 to both sides. So now I have y equals 12x plus 30. And now I consider it equal to this equation because they're both equal to y. So if x squared plus 11x minus 12 is equal to 12x plus 30, I'm going to bring everything over to the same side so it could be equal to 0. So I'm going to subtract 12x and subtract 30 from both sides. So now I'm left with x squared minus x minus 42 is equal to 0. Now numbers that multiply to negative 42 and add up to negative 1. It's going to be 6 and 7, but the 7 is going to be negative. So now my factors are x plus 6 and x minus 7 is equal to 0. The negative 6 is going to make this 0, and the 7 is going to make this 0. So here are my two x values, and I'm going to plug them in into this equation here to get the y values. So one y value is going to be 12 times negative 6 plus 30. That's gonna be -72 plus 30 is equal to -42. So -6 comma -42 is one solution. And then if I plug in the 7, 12 times 7 is 30. It's 84 plus 30. That's going to be 114. So the other solution is 7 comma 114. And you could check both of these answers using decimals if you like. Now we're going to get into a word problem, because you do have a word problem in this homework. So let's read it. So since opening day, attendance at pool A has increased steadily, while attendance at pool B first rose, then fell. Equations modeling the daily attendance, that's what Y stands for, and the number of days since opening, that's what X stands for, are shown below. On what days was the attendance the same at both pools? So what days? So we're looking for the X values here for number 1. To find that, we have two equations equal to Y, so we could set them equal to each other. So x negative x squared plus 39x plus 64 is equal to 28x plus 4. Now I want to get them all on the same side and set it equal to 0. Notice that my x squared is negative, so I'm going to move everything from the left to the right to make sure I have a positive x squared. I'm going to add x squared. I'm going to subtract 39x. And I'm going to subtract 64 on both sides. Okay, so now I'm done. So 0 on the left, positive x squared, 28 minus 39. That's going to be negative 11x. And then 4 minus 64, that's going to be negative 60. So now I'm looking for numbers that multiply to negative 60 and add up to negative 11. So I know 4 and 15 multiply to 60, but I need one of them to be negative. I need the bigger number to be negative to get negative 11. So now my factors are x minus 4, I'm sorry, x plus 4 and x minus 15. So my x values are negative 4 and 15. So on what days was the attendance the same at both pools? So at day negative 4 and at day 15. But in this problem, only one of these answers makes sense. So the only correct answer is x is equal to 15. So the attendance was the same on day 15. And then second question, what was the attendance? So going back to the question, the daily attendance is the y value. So if I have the x value, I will plug it in to get the y value. So I'm gonna plug it into the first equation. Y is equal to 28 times 15 plus 4. 28 times 15 is 420, plus 4 is 424. So the attendance was 424 people. And that's it.